There's something almost magical about the way Albert Einstein looked at the world. While most scientists relied on laboratories filled with equipment, Einstein often worked with nothing more than imagination. Yet somehow, his ideas reshaped the entire foundation of physics. What makes his work so fascinating is that many of his most famous experiments weren't experiments in the traditional sense at all. They were thought experiments. Simple, almost story-like scenarios that anyone could picture, yet powerful enough to unlock the deepest secrets of the universe. Imagine sitting on a beam of light, or being inside an elevator floating in space. These aren't just strange ideas, they are the very questions that led Einstein to challenge everything we thought we knew about time, space, and reality itself. And the crazy part? These mental experiments didn't just stay in his head. They were later proven to be real, measurable, and incredibly accurate. Today, technologies like GPS systems and solar panels quietly depend on the very principles he once imagined. In this video, we're diving into 5 of Einstein's most powerful experiments, the ones that didn't just push science forward, but completely changed how we understand the universe. Each one starts with a simple question, but leads to an answer that feels almost unbelievable. So as we go through them, try not to think like a scientist. Think like Einstein did. Curious, open-minded, and just a little bit bold. One of the most famous ideas that shaped Albert Einstein's thinking came from a question he first imagined as a teenager. What would it look like if you could travel alongside a beam of light? At first, it sounds almost like science fiction, but this simple question led to a serious problem in physics. According to the laws known at the time, if you moved fast enough, you should be able to catch up to light and see it frozen in place, like a still wave. But there was just one issue. No one had ever observed light behaving that way. This contradiction bothered Einstein deeply, and instead of ignoring it, he leaned into it. He realized that the problem wasn't with light, it was with our understanding of space and time. From this thought experiment, Einstein began to develop what would later become the special relativity. The shocking conclusion? No matter how fast you travel, the speed of light always remains constant. That means time and space must adjust themselves to make that possible. In other words, time can slow down, and distances can shrink, all depending on how fast you're moving. It's not just theory either. This effect has been measured and confirmed countless times, especially with fast-moving particles and satellites orbiting Earth. What started as a curious what-if question turned into a complete rewrite of reality. And the wildest part is, Einstein didn't need a lab to figure this out, just imagination, logic, and the courage to question what everyone else assumed was already true. Another one of Albert Einstein's most brilliant insights came from an idea so simple it almost feels obvious, yet it completely changed how we understand gravity. Imagine you're inside a closed elevator, no windows, no way to see outside. Now picture 2 different scenarios. In the first, the elevator is sitting still on Earth, and you feel your normal weight pulling you down. In the second, the elevator is floating far out in space, but suddenly it starts accelerating upward at a constant rate. Here's the strange part. In both situations, everything would feel exactly the same. You'd still feel pressed to the floor, objects would fall the same way, and there would be no experiment you could do inside that elevator to tell the difference. This idea became the foundation of what Einstein called the equivalence principle. It suggests that gravity and acceleration are, in a deep sense, the same thing. But Einstein didn't stop there. He took this realization further and proposed that gravity isn't really a force pulling objects together, as Isaac Newton had described. Instead, massive objects like planets and stars actually bend the fabric of space and time itself, and what we feel as gravity is simply objects following those curves. This led directly to his theory of general relativity, which has been tested and confirmed in incredible ways, from the bending of light around the sun to the recent detection of gravitational waves. All of that from just imagining being stuck in an elevator with no windows. At the time when Albert Einstein was developing his ideas, not everyone even believed that atoms were real. It sounds surprising today, but back then, atoms were still considered more of a theoretical concept than a proven reality. Then came a strange observation known as Brownian motion, the jittery, unpredictable movement of tiny particles suspended in a liquid, first noticed by botanist Robert Brown. Under a microscope, these particles seemed to dance around randomly, with no clear cause. Many scientists were puzzled by it, unsure whether it was due to some unknown life force or simply a mystery of nature. But Einstein saw something deeper. In 1905, he proposed that this random motion was actually caused by countless invisible atoms and molecules constantly colliding with those tiny particles. Even though you couldn't see the atoms themselves, their effects were visible through this chaotic movement. What made Einstein's work so powerful wasn't just the explanation, it was that he provided a way to mathematically predict and measure this motion. And when scientists tested his predictions, they matched perfectly. For the first time, atoms weren't just a theory anymore. They were real, measurable, and incredibly accurate. Today, technologies like GPS systems and solar panels quietly depend on the very principles he once imagined. It's a reminder that sometimes the biggest breakthroughs don't come from looking at the stars, but from carefully observing the smallest details right in front of us. One of the most mind-bending consequences of Albert Einstein's work comes from an idea often called the twin paradox. Imagine two identical twins. One stays on Earth, living a normal life, while the other boards a spaceship and travels at a speed close to the speed of light before eventually returning home. According to everyday intuition, you'd expect both twins to age the same, but Einstein's theory tells a very different story. The traveling twin would actually come back younger than the one who stayed behind. It sounds impossible at first, almost like a science fiction plot, but it's a direct result of time dilation, a core prediction of special relativity. The faster you move through space, the slower you move through time, at least relative to someone else. And this isn't just a theoretical curiosity. Scientists have tested this effect using incredibly precise atomic clocks placed on fast-moving airplanes and satellites, and the results match Einstein's predictions with stunning accuracy. Even astronauts aboard spacecraft age ever so slightly slower than people on Earth. The difference is tiny at normal speeds, but as you approach the speed of light, it becomes dramatic. What makes this experiment so powerful is how personal it feels. It's not about distant galaxies or abstract equations, but about time itself, something we all experience every moment. Einstein showed us that time isn't fixed or universal. It's flexible, relative, and deeply connected to motion. And once you truly grasp that idea, it changes the way you think about reality forever.